So in this video, we are going to talk about pressure in fluids and atmospheric pressure. Let's get started with the concept thrust. Thrust is a force acting normally on a surface. A body, when placed on a surface, exerts a thrust on the surface equal to its weight. Units of thrust are same as that of force or weight because thrust is also a kind of force. So SI unit of thrust will be Newton. 1 Newton equals to 1 GF nearly. 1000 gram force equals to 1 kilogram force, and 1 kilogram force equals to 10 Newton nearly. Here you can see some examples of thrust, that boy is standing and his area on the same surface is less, hence the thrust will be more than the boy who is laying on the same surface. Now pressure. Pressure equals to force by area. Unit of pressure is Pascal. 1 Pascal equals to 1 Newton meter square. 1 Pascal is the pressure exerted by a thrust of 1 Newton on a surface area of 1 meter square. That is why 1 kPa equals to 1000 kPa. Unit of atmospheric pressure is ATM. 1 ATM equals to 76 centimeter of Hg equals to 760 millimeter of Hg equals to 760 torr equals to 1.013 into 10 to the power 5 Pascal equals to 1.013 bar. Factors affecting pressure. The pressure on a surface depends on the following two factors. First, on the area of the surface on which the thrust acts, and second, on the magnitude of thrust acting on the surface. For example, this has a weight of 100 Newton. Same force, different area, different pressure. This is lying on the surface. It is covering more area, hence it will exert less pressure. This brick is also having same weight, but since it is covering the lesser area, this is why it will have more pressure. So lesser the area, more will be the pressure, more will be the thrust. Examples of pressure in our daily life. Decrease in area increases the pressure. As we have already seen, we hammer the nail into the wall through the pointed end because the pointed end of nail with lesser area exerts more pressure. Similarly, it is easier to walk on soft sand if we have flat shoes rather than shoes with sharp heels because shoes with sharp heels will cause uncomfortability. And third, sharp edge of cutting tools have very small area of contact, so pressure applied by force is more, and hence it can cut anything into two pieces. Increase in area decreases the pressure. It also has its own implication, like the number of tires in truck is used to balance the thrust which is acting upon the surface which truck is moving throughout. Then we have camel, who is easily comfortable in desert as compared to horse because camel has broader feet and this exerts lesser pressure on desert, which makes camel to move swiftly. Then we have skiing. Long flat skies have a large area of contact with the snow. This is why any skier could easily pave their way through the snow. Then we have caterpillar wheels. This also increases the surface area and hence exert lesser pressure on the surface which it was acting on. This is why it is used in military tanks as well as in JCBs. Some more examples: broad foundation of buildings, railway tracks with wooden slippers, school bags having wide straps. Then turban increases the area of contact of load and head. That is why laborers used to wear turban in order to increase the pressure on their head. Difference between thrust and pressure. Thrust is basically sum total of force acting perpendicular to a surface. Pressure is thrust acting per unit area. Thrust is independent of the area over which force is applied. Pressure depends on the area on which force acts. Thrust, since it is a kind of force, its SI unit will be Newton. Pressure, the SI unit of pressure is Pascal or Newton per meter square. Then we have pressure in liquid. Liquid exerts pressure at the bottom of container, as you can see in this chart, and liquid exerts pressure in all the direction. If we fill a balloon with liquid, it will exert pressure in all the directions, either upwards, either downwards, northwards, eastwards. Liquid also exerts pressure sideways on the walls of container. Pressure exerted by liquid column. The thrust exerted on the surface PQ equals to weight of the liquid column PQRS. The thrust exerted on the surface PQ is equals to weight of the liquid column PQRS equals to volume of liquid column PQRS into density into G. Area of base PQ into height into density into G, and hence we will have formula AHPG to calculate pressure exerted by a liquid column. So the thrust is exerted on the surface PQ of area A. Therefore, pressure will be thrust on surface by area of surface. AHPG by A equals to HPG. Factors affecting the pressure at a point in liquid. Depth of the point below the free surface, density of liquid, acceleration due to gravity. These three are the factors which affect the pressure at a point in liquid. Now, liquid pressure increases with the height of liquid column above the point, so height is also a factor. Then we have liquid pressure increases with the increase in density. Denser the liquid, more will be the liquid pressure inside it. So total pressure at a point in liquid equals to PATM plus PLIQ equals to PO plus HRG. Now laws of liquid pressure. Inside a liquid, pressure increases with the increase in depth from the free surface. Then in a stationary liquid, pressure is same in all points on a horizontal plane. Then we have pressure is same in all direction about a point inside a liquid, and pressure at same depth is different in different liquids. It increases with the increase in density of the liquid. As for example, the liquid pressure in water will be lesser than the liquid pressure in honey, because honey has more density than the water. Then a liquid seeks its own level. You can see hydrostatic paradox here. Now consequences of liquid pressure. Thickness of a wall of a dam is increased towards the bottom so that it can contain huge amount of potential energy of water. Then we have water supply tank is placed at a height in order to supply the water, distribute the water throughout the area. The deep sea divers require special chutes in order to overcome the liquid pressure and dive into the seas. Then we have Pascal's law. Pascal's law states that the pressure exerted anywhere in a confined liquid is transmitted equally and undiminished in all directions throughout the liquid. Here we have one of the demonstration of Pascal's law. Principle of hydraulic machine. How hydraulic machines work. We have some formula. P1 equals to P2 as per the Pascal law. Hence force 1 will be equal to F2. A1 equals to A2 area. And in order to get F2, we can calculate it by multiplying F1 into A2 by these two equations, equation 1 and equation 2. Now a small force applies on a smaller piston is transmitted to produce a large force on a bigger piston. Now the concept of atmospheric pressure. This is basically the atmosphere. The layer beyond our earth is called atmosphere. The blood pressure makes the effect of atmospheric pressure ineffective so that we can live life here in earth. The thrust on unit area of the earth's surface due to column of air is known as atmospheric pressure. Atmospheric pressure is about 10 to the power 5 Newton per meter squared. So a thrust of 1 lakh Newton acts on every meter square of the surface of objects on earth. Proof of the existence of atmospheric pressure. So these demonstrations are some of the proof of the existence of atmospheric pressure. You can do it by yourself and feel the atmospheric pressure. Some more examples. Atmospheric pressure acts on the oil due to the air entering the tent through the upper hole. Then we have a special suit worn by mountaineers and astronauts in order to overcome the atmospheric pressure. Feet of lizard behave like a suction pad. Nose bleeding occurs at high altitude because at high altitude atmospheric pressure is so low. Then we have barometers. Barometers are basically, you can see the image of barometers. These are used to measure the atmospheric pressure at a given place at a given time. These can also be used to forecast the upcoming weather. As an altimeter, it can also be used. Now variation in atmospheric pressure with altitude. Atmospheric pressure decreases with increase in altitude. That means as above as we go, atmospheric pressure will decrease. It decreases linearly with increase in height. It decreases non-linearly with change in density of atmospheric air. That is, density of air itself decreases non-linearly with altitude. Weather forecasting. How barometer can be used with the phenomenon of atmospheric pressure to forecast weather, like change in barometric height. If it falls suddenly, that means pressure at the place will decrease suddenly, and this is basically a forecast of coming of a storm or a cyclone. If the barometric height falls gradually, pressure is slowly decreasing due to increase in moisture, that is basically the possibility of rain. If the biometric height rises suddenly, pressure at the place is suddenly rising and air will away from that place to nearby low pressure area. That means upcoming weather is going to be extremely dry. Then if the barometric height rises gradually, that means pressure at that place is rising slowly as the moisture in the air is decreasing. That means the upcoming weather is going to be a dry weather. Then if the barometric height has shown no abrupt changes, that means atmospheric pressure is fairly the same, and weather forecast, weather will remain almost unchanged, constant. Here you can see the image of barometer, which is used to measure the atmospheric pressure. Then we have altimeter. Altimeter is a specially designed and calibrated NRI barometer for the measurement of altitude depending upon the decrease in atmospheric pressure with increase in the height of a place above sea level. Here you can see the image of altimeter. Now that's all in the chapter. We have some numericals for you too, which I would suggest that you should solve by yourself. Like, first is a hammer exerts a force of 1.5 Newton on each of the two nails A and B. The area of cross section of tip of nail A is 2 mm square while that of nail B is 6 mm square. Calculate pressure on each in Pascal. The solution is given there, but I would suggest you to solve by yourself. Next numerical is a block of iron of mass 7.5 kg and of dimension. This is basically the dimension of block of iron. It is a, I think, cuboid. It is 12 centimeter, 8 centimeter, 10 centimeter. It is kept on a tabletop on its base of side 12 centimeter into 8 centimeter. You have to calculate the thrust, you have to calculate the pressure exerted on the tabletop, and 1 kgf equals to 10 Newton. This value you have to take instead of kgf. And you have data given, you can solve it by yourself. Third is a vessel contains water up to a height of 1.5 meter, taking density of water to be 10 kg per meter cube, acceleration due to gravity 9.8 meter per second square, and area of the base of vessel 100 centimeter square. Calculate the pressure and thrust at the base of vessel. You have data given, and now you can solve it by yourself. I'd encourage you to solve it by yourself. Then you have to calculate the height of water column that will exert on its base the same pressure as 70 centimeter column of mercury. The density of mercury is 13.6 gram per centimeter cube. Will the height of the water column in the above question change if the area of cross section of water column is made wider? You have data given, you have to calculate the height, and so as you go. Next is, in a hydraulic machine, a force of 2 Newton is applied on the piston of area of 10 centimeter square. What force is obtained on its piston of area of cross section 100 meter square? We have data given, and you should solve it by yourself. Next question. Convert 1 mm of Hg into Pascal. You have to take density of Hg at this and gravitational acceleration due to gravity at 9.8 meter per second square. This is so simple. You have to just put the formula of Hpg equals to P and get the answer. At sea level, next question is, at sea level the atmospheric pressure is 76 centimeter of Hg. If air pressure falls by 10 mm of Hg per 120 meter of extent, what is the height of a hill where the barometer reads 70 centimeter of Hg? State the assumption made by you. You have data given, just put the formula and get the answer. At sea level, the atmospheric pressure is 1.04 into 10 to the power 5 Pascal. Assuming the value of G is 10 meter per second square and density of air to be uniform and equal to 1.3 kg per meter cube, find the height of atmosphere. So you have data given, and you can solve the numericals by yourself. This is simple putting the formula, getting the answer. That's all in this chapter. See you in the next chapter.